All right, we're going to finish this up with 9-6. So quadratic formula and discriminant. These are basically two formulas. So if you know the formulas, you kind of know what you're doing in this section. That's kind of the star of the show, is if you get the formula down, or if you write down the formula and you can use it, then you're good to go. We're going to learn about the discriminant, quadratic formula, and we're going to learn about the word root. So those are going to be our vocabs. And like I said, today the goal is just use the quadratic formula. Note the operative word here is use, not memorize for today. So it's okay if you just have the quadratic formula with you and you just use it for the problems. So I'm going to skip the explore and reason section for this section. In a nutshell, wrong window. What it's trying to do is we had these parabolas. We can tell this one has two solutions because it hits the x-axis twice. If we change it, we can make it hit the x-axis just once. That has one solution. And remember, if it goes above the x-axis, that would be no solution. So that's kind of what the whole explore and reason section was trying to tell you. Let's do it in like the 30 seconds instead of like 5 minutes for the explore and reason section, though. So example 1 has us actually derive the quadratic formula. Now, this is something that you're not expected to do, but it is something that's useful to see because it connects this section with the one we just did, with the completing the square. So if you want to skip over this section, feel free to. Make sure you do write down the quadratic formula that I'm going to show you right here. And so this is a formula that lets you solve any quadratic equation. So notice it's called the formula because we're going to use the formula to solve an equation, just like a chemical formula might be used to solve a chemistry equation. So our formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then for those of you who are used to seeing things in calculators, you're going to want to make sure you have these things in parentheses. And then we want to also say that this has to be 4ax squared plus bx plus c equals 0. And that equation's the quadratic equation part. So the formula is over here, the equation is over here. Now that looks probably familiar because that's just standard form for a quadratic. The important thing is to know that it is in standard form, and it does equal 0. So if you remember when we did that, when we solved them all the way back when we graphed, we always tried to make everything on one side equal 0. You need that for this section too. Okay, so what we're going to do is we're going to derive it, like I said. So we've got our general equation over here, so we're going to solve it just like we did with the last section. So we know that in order to start completing the square, the first thing we got to do is make sure x squared is totally by itself. So you have to divide everything by a. So we get x squared plus b over ax plus c over a equals 0. So now we're ready. The middle term, it looks weird, but we're going to state that b is b over a. So if we divide that by 2, we get b over 2a. And if we square it, we get b squared over 4a squared. So that's the reason why I picked the capital letters here, just to remember. The lowercase letters I'll just leave as what we did last time. So now we got our capital letters. So still though, this is like our new c term. So we get x squared plus b over a x plus b squared over 4a squared minus b squared over 4a squared. That doesn't look like a very good squared. Plus c over a equals 0. All right, so far so good. We're going to go ahead and make our perfect square. So that gives us x squared plus b over 2a, not x squared. That's going to be quantity squared. And then we're going to combine our like terms over here. So if I want to combine the like terms, I have to make that a 4 and a squared. So I need to multiply the top by 4 and a. So this is going to be minus b squared plus 4ac all over 4a squared. Still equals 0. So now we got to solve it like we would solve any other equation. We got to try and get the squared piece by itself. Luckily, that's not too bad with this one. We can just take this and we can add that to both sides. I'm going to shorthand that and just say plus this. So we get x plus b over 2a squared equals b squared minus 4ac all over 4a squared. So this switch, because I had to switch my sign, so this minus sign, when we add it over, it becomes a plus. This plus sign, I'd have to subtract it. That's why we get the minus sign right there. All right, so looks like we're almost there, almost clear. But we got to take the square root now. So we're going to take the square root of both sides. So those will cancel each other out. So that means we've got x plus b over 2a equals, I can't do the square root. We saw a lot of them when we did some of the practices where we can't do the square root at the top, but we could square root the bottom. Square root of 4 is 2, square root of a squared is a. To get the x by itself, we need to then subtract this b over 2a. Which gives us x equals negative b. Since these are the same denominator, we can just make one giant denominator. Plus or minus square root of b squared minus 4ac all over 2a. And so, yeah, we can derive it. We can get our quadratic formula right away. And it does come from the last section. It is a lot of algebra stuff. But like I said, this isn't something you're going to be expected to do or expected to know where it comes from. You're going to be expected to use the formula. It is important to see where it comes from, though, just so you can see there is a reason behind it. It's a mathematical proof. So we then have to say the number of solutions that the quadratic formula can give. And if we think about it, we just said the quadratic formula was related to the parabola. So it makes sense that there's 2. If you want, you could talk about the parabola itself. Or if we look here, we've got this square root part that we have to plus and minus something. So we can see at most, we would have the positive version and the negative version of the square root of b squared minus 4ac. So at most, we can have 2 solutions there. Now, it's possible that we have less, and that kind of makes sense again, because we know our graphs. We've done a lot of graphing. We've done a lot of solving. We've seen where we can get 2 solutions, 1 solution, and no solution. But that's our algebra way to do it. So now that we've seen the quadratic formula, we're going to use the quadratic formula. So like we said, to use it, we got to get it in standard form. So we're just going to subtract 4x from both sides. X squared minus 4x minus 7 equals 0. And you literally just plug everything in. We got to find out what A, B, and C are. So A is always the first number. There's like a 1 out front there, even though it's not really written, so we keep that as a 1. B is the second number. We make that negative 4. C is the last number. We make that negative 7. So you can see all the letters, when we choose the numbers for them, they keep the signs, but they lose all the variables. So you don't want to put any x's or x squareds in the quadratic formula. It's just going to be numbers in the quadratic formula. The only x is like what our answer is going to be, what our solution is. But when we use the quadratic formula, we're only going to put the numbers in. So the QF is negative b plus or minus the square root of b squared minus 4ac all over 2a, and we just plug everything in. Negative b, so b is negative 4. Plus minus is in purple because that's part of the formula. Same with this negative sign out front. Square root of b, so b is again -4. Squared is part of the formula, so I'm going to keep it in purple. Minus 4 is part of the formula, so it's in purple. A is red, so make that an A. And then we've got a -7 for C. All right, the division sign is part of the formula, so I'm going to keep that in purple. The 2 is part of the formula, so I'm going to keep that in purple. And then I'm going to make the 1 a red one. So you can see with the format, everything that's in purple is just going to stay the same every single time for every single problem. The only thing that's going to change are going to be those the other colored numbers are for whatever we have for our A, B, and C. So at this point, we're going to keep it going. These down a bit. There's not really too much left to do. We're just going to simplify a little bit. So out front, we've got -4, which is just 4. Inside the square root, we've got -4 squared is 16. 4 times 1 times 7 is -28. And then 2 times 1 is 2. So we're going to do a little bit more simplification. 16 minus -28 is like 16 plus 28. So that's going to be 16. Didn't grab everything. Here we go. 44. Over 2. And then this is going to be the kind of the tricky part, is we have to remember what we're doing when we want to simplify. Since we do have this plus minus, I can't just divide the 4 and the 2. That's not allowed. I can split it up into 2. I can say 4 divided by 2 is 2. Plus or minus the square root of 44 divided by 2. I can split it up into 2 parts if I want. But the nice thing is, if we wanted to break down square root of 44, we can, square root of 4 and square root 11. So we could, if we wanted to, call this 2 plus or minus square root of 11. Because 2 square root of 11 over 2, the 2's are going to cancel. And that'll be my final answer. So you see, I didn't really want to get a decimal for this one. So just like when we did completing the square, we said sometimes they want the fractions as answers. When we did the simplifying, sometimes they wanted exact answers. They can want exact answers in this section too. If they want exact answers, then yeah, you just simplify it down. So we'll give the try a go. If you want to give it a go on your own, those are the 2 we're going to do. But the goal is get everything in standard form first. So for this one, I'm actually going to add 4x to both sides and then subtract 21 from both sides to get 0 equals x squared plus 4x minus 21. So again, the whole idea is it's x squared and then the x's and then the number at the end. All right, so -b plus or minus the square root of b squared minus 4 times a times c. It's a -21 for c over 2 times 1. All right, well, that's going to be -4 plus or minus square root of 16 plus, because I got 2 minus signs there, 4 times 1 is 81. No, 4 times 1 is 84 over 2. 18 or 16 and 84 makes 100. So -4 plus or minus the square root of 100 over 2. We know the square root of 100. Square root of 100 is 10. So -4 plus or minus 10 over 2. So this is going to become -2 plus or minus 5, which is -3 and -7. So they're going to be my 2 answers for that one. On the other side, x squared, I've got to subtract the 24 from both sides. So minus 2x minus 24 equals 0. So we just throw it in the formula at this point. So -2 plus or minus the square root of -2 squared minus 4 times 1 times -24 all over 2 times 1 again. Okay, well, that's not too bad. So that's going to be 2 plus or minus the square root of 4. And then we've got 4 times 1 times 24. So it's going to be a plus 96. Yeah. So it looks like we got over 2 again. Looks like we got 2 plus or minus 10 again over 2. So 1 plus or minus 5. So that's going to be -4 or 6. So it looks like that's what we're going to get for our results. Cool. So moving on, we can do an application with it. We can see here things are starting to get a little bit scarier because now we've got a little decimal here. So we're trying to model the where this frog is going to land. And we're given the function -16t squared plus 10t plus 0.3. How many seconds is the frog in the air before landing on the ground? Round your answer to the nearest hundredth. So just like before, when we see this, we know we're going to have to put our answer into a calculator at some point. Now the nice thing is this equation's already in standard form, so we just have to set up the quadratic formula. So -b plus or minus the square root of b squared minus 4. A this time is -16. And C is 0.75 over 2 times -16. All right. So at this point, you throw that into a calculator. That's it. That's all you got to do. There's no point in writing out any simplifications because I wanted it rounded to the nearest hundredth. If you do put it in the calculator, you got to do the plus first, and then just do a subtraction second, and that'll get you your 2 answers. I don't really feel like that, so what I did is I programmed Desmos to do it for me. Feel free to also program to do it and have program Desmos to do it for you. I know A is -16. B is going to be 10. And then C, they gave me 2 different equations, but I'm going to go with the 0.75 equation. I'm going to pick this one right now. I think I got them flip-flopped. I did. That's why that's a little confusing. There we go. That makes more sense. We'll still keep that right there, though. And we get 0.75 for C. There we go. And guess what? I programmed it. So there are my answers down there. R1 for the first root, R2 for the second root. I could click on them in Desmos if I wanted to click on them here. I could also do that. But since we're doing the quadratic formula and we're not just solving by graphing, I did have the quadratic formula over to the side. Again, since it's a real world problem, we're dealing with time. I'm going to ignore this -1 because a negative time doesn't make sense. So 0.69. Now, the other reason why we want to do it over here with the quadratic formula is in case they want us to be more precise. Like Desmos on the graph automatically rounds it here. I don't know if that's perfectly rounded. So I can look at my real answer and say, oh, it's 0.69267. So I could give an answer to 4 decimals, 5 decimals, 7 decimals. But the 2 decimals, it's 0.69, or yeah, just 0.69. So we'll stick with the 2 decimals from before. Of course, we also get the -0.07, which we immediately say that's not going to happen because that would be a negative time. So we just ignore that one. And that's it. We're already done. So the whole point of this lesson is just to be able to plug the numbers into the formula and get the 2 answers. So then example 3 down here, they give us the second part, which is basically just the same thing with another equation. This time all they did was they changed the number at the end to be 0.3. And this is the cool thing about programming it is now I just need to say, okay, C is 0.3 now. What's my answer? 0.65. Okay, I'm done. That's it. Nothing to it. You just have to have the formula handy. You can memorize it if you want, not a requirement. So example 4 talks about something called the discriminant. So we had the quadratic formula. And the quadratic formula is handy because it tells us what our two answers are. Negative b plus or minus the square root of b squared minus 4ac all over 2a. But what if I wanted to find out if I even had to use the quadratic formula? Because sometimes, like we said, we could get one answer, 0 answers, or 2 answers. Well, if we get 0 answers, why would I bother using the quadratic formula? That sounds like a waste of time. If I could figure out if there were no answers right away, that would be pretty helpful. And that's what our discriminant does. So the discriminant is just going to tell us how many solutions we have. It doesn't tell us what they are, just tells us how many. And the discriminant is another formula. So just like the quadratic formula, it's something that you won't need to memorize, but you should be able to use it to find out how many solutions exist. The discriminant formula is b squared minus 4ac. That might look familiar because it's kind of the same inside part as the quadratic formula. So that's kind of cool. So it looks like we just have another formula that comes from one of our formulas. So why would that be helpful? Well, it tells us how many roots we have. So a root's just another word for a solution of the quadratic. And if we think about it, we want to think about when we were doing the square root ones back in section 9.3. How often, or sorry, 9.4. How often would we, or what would be our situation where we would get no solutions? Well, you get 0 solutions if this is negative, because we said we couldn't do square roots of negatives. So if b squared minus 4ac is less than 0. So the math way to say it is to say if it's less than 0, you could say negative if you want. And again, if we did that, we'd get a graph that looks either like something like that, where we just don't hit the x-axis. So we get 0 solutions or 0 roots. If we get 1 solution, I'll use the word root here. We'll get that if b squared minus 4ac is exactly equal to 0. Because if we did the positive square root of 0 and the negative square root of 0, we'd have the same answer. So that's something that just touches once. So it only touches once. It's got 1 root or 1 solution. The only other option we have is 2 roots or 2 solutions. And that's if b squared minus 4ac is greater than 0. Or if it's positive. So again, the graph for that might look something like this, where we have 1, 2 solutions, where we hit twice. So this is pretty cool, because if we just do this part, the b squared minus 4ac, and it turns out that it's negative, we don't need to bother with the whole quadratic formula. And just solving that small equation seems like it's going to be even faster than graphing. So we could even just do this if you don't want to graph. If you get 1 solution, well, then you have to go through the whole process. Same deal if you have 2 solutions. But again, depending on how the equation looks, you could then choose your method. So if it looks like it's a good completing the square, complete the square. If it looks like it's factorable, factor it. If you just want to graph it because you feel like graphing it, go ahead and graph it. So we're going to use the discriminant to find the roots of each of these equations. So again, all we're doing is we're using the equation b squared minus 4ac. So in this case, we're going to do negative 10 squared, since that's what b is, minus 4 times a is 1 times c is 25. So 100 minus 100, which is 0. And so we have to remember that 0 means 1 root. So our final answer isn't the number 0. Our final answer is 1 root. So that's all you're going to do is say how many roots there are. On the other side, for part B, in this case, we're going to use the exact same equation, b squared minus 4ac. So negative 6 squared minus 4 times a is negative 1 times c is negative 10. So 36. So that's 1, 2, 3 negatives. And then we get 40 or negative 4. So our answer is going to be 0 roots. And 0 roots because negative 4 is, well, negative. So 0 roots. That's it. That's all you got to do for those. Now, if you want, again, since I was programming the whole quadratic formula in, I might as well programmed in the discriminant. So I programmed the discriminant in as well. So if I really wanted to know what number it was, I could just tap, type them in, and then it'll just give me the answer right away. So it's kind of cool. And that's it. That's actually the end of this section. They got the summary right here. So again, we did the quadratic formula. There it is. I guess I think they did they use different colors than I do? I don't know. But there's our quadratic formula. Again, this is the star of the show for today. Write that down, have that handy, or be looking at this when you do some of the problems for this section. There's the discriminant. That's the other formula that you need. So those are the two formulas that you need to have. Other than that, should be good to go. So this is pretty fun. This is kind of the last one we're doing for the year, so make sure you get everything done. A little bit different to do all these digital lessons, but I thought it was kind of fun to do some of the recordings and stuff. Hopefully you had fun too, watching all the lessons. Take care and have a good summer break.